Good evening everyone. I am Dr. Bedupari. Today we are going to discuss the cardinal unity approach. So first start with the assumptions. So what are the assumptions of the cardinal unity approach? First one is utility. Is measured cardinally, means it can be measured in numbers and the unit will be util. The second assumption is the consumer are rational in nature. Or we can say they are rational consumer. That means they always try to maximize their net utility or utility. Third assumption, marginal utility of money is constant. Here we assume that marginal utility of money is lambda. Now fourth assumption, price of a commodity is given to the consumer, that is, consumer has no control over the price of a commodity. Fifth assumption, utility is additive in nature, that is, utility from different goods are independent to each other. So based on these assumptions, we'll try to derive the demand curve. Derive the demand curve. from the cardinality approach. Here utility is a function of quantity of a commodity. Q is the quantity of a good. The total utility function is concave to the quantity axis. Now if I draw the total utility curve, it will look like this, where we will measure quantity in the horizontal axis and so this is the total utility, this is marginal utility, this is quantity, and according through the vertical axis we are measuring total utility and marginal utility. When total utility is maximum, marginal utility become 0, and marginal utility is greater than 0 when total utility is rising. When total utility will fall, the marginal utility is less than 0. So that means it has 3 phases: phase 1, phase 2 and phase 3. In case of phase 1, total utility is rising, marginal utility is greater than 0. In phase 2, total utility become maximum and marginal utility is equal to 0. And phase 3, total utility is falling and marginal utility is less than 0. What is marginal utility? Marginal utility is difference total utility from n unit minus total utility of n minus 1. So unit change in the total utility is the marginal utility. In derivation concept, dq of marginal utility of total utility is equal to marginal utility. So this is the function, total utility is a function of Q. So now coming back to the cardinal utility approach, how can we derive, how to derive the demand curve in cardinal utility approach. Here we can derive the net utility What is net utility? Net utility is nothing but the difference between the gain and sacrifice. Gain means when we are consuming any commodity, suppose Q, minus how much sacrifice I am having, means how much money I am paying. So if I am consuming q amount of unit of commodity, and if I paying p for each unit of products, so qp is the expenditure I am having. So if the marginal utility of money is lambda, then this will be my sacrifice. The unit of the sacrifice is util, and the gain have the same unit, util, because gain is nothing but the total utility function of q, and the unit is util. So the net utility is difference between the gain I am getting by consuming that product and the sacrifice, how much amount of money I am paying for that commodity. So sacrifice and gain both are in utility term. So now, as the consumer is rational consumer, the objective is to maximize net utility. So if you maximize the net utility n, what will be the first order condition? So dn by dq will be 0, and what will be the second order condition? dn d square n by dq square is less than 0. So now try to do the derivation. So here we get n is equal to f of q minus lambda pq. So if we do the derivative with respect to q to the both side, I will get dn by dq is equal to f dash q minus lambda p, as lambda and p are constant which is mentioned in assumption. So according to the first order condition, dn by dq is equal to 0 into the first order condition. So 0 is equal to 0 is equal to f dash q minus del p, or f dash q is equal to lambda p. What is f dash? F dash q is nothing but del u by del q is equal to marginal utility, or marginal is equal to lambda p, or p is equal to mu by lambda. So this is the demand curve equation. So in this way we can derive the equation of the demand curve. Now what will be the second order condition? Now we have to satisfy the second order condition. So dn by dk is equal to what we get, f dash q minus lambda p. Then again derivative with respect to q to the both side, will get d2n by dq square is equal to f double dash q minus d dq of lambda p, as both lambda p are constant, so this term will be is equal to 0. So we will get d square n by dq square is equal to d dq of marginal utility. So from the assumption and the function itself, graphically we show that marginal utility is diminishing, means when q will rise, marginal utility will fall. If you go back to the figure, here you will see, if we move from left to right, means when q is rising, marginal utility is falling. So you can, this is the marginal utility for q is equal to 1, this is the marginal utility for q is equal to 2, this is the marginal utility is equal to q is equal to 3. You see, this is the amount of marginal utility. So marginal utility when q is equal to 1, marginal utility q is equal to 2, marginal utility is q is equal to 3. So when my q is rising, marginal utility is continuously falling. So if I do the derivative with respect to q, so what will happen? It will be less than 0 according to the assumption. So this is the most important assumption in cardinal utility approach, that according to the cardinal utility approach we have diminishing marginal utility. So in this way we can derive the demand curve, also we can maximize the net utility. Now can we draw the demand curve and how it will look? So if I draw, then our demand curve will look like this. Here I am considering q because I am drawing the demand curve, so it will show the relationship between pq. It will show the relationship between p and q. This is the law of demand. So there will be inverse relation between p and q. So the shape is rectangular hyperbola. What is rectangular hyperbola? Rectangular hyperbola is nothing but it's a curve, and whatever rectangle I'll get from this curve, suppose this is area A and this is area B. The rectangle, the area of A and B are same. So this is Q1, this is Q2, this is P1, this is P2. So the expenditure from both the means P1 Q1 is equal to P2 Q2. So the change, so the multiplication of the expenditure will be always same. So what will be the elasticity? Of this demand curve? Let's try to find it out. Suppose I have a demand curve. The equation of the demand curve is M is equal to P1 Q1 plus P2 Q2. This is the equation of the budget line. Now derivation with respect to q1 will get dm by dq1 equals to d dq1 of p1 q1 plus d dq1 p2 q2. As according to cardinal tree approach, utility is additive in nature. So q2 is totally independent of p1 or q1. So this part will be equals to 0. Now I'll end up with a dq1 of p1 q1. So we'll get dm by dq1 equals to d dq of p1 into p1 plus q1 into d p1 d q1. The total derivative I am doing using uv law, d dx of uv. Now as money is constant, money income is constant, then this part will be 0, or 0 is equal to p1 plus q into q1 into dp1 dq1, or p1 is equal to minus q1 dp1 dq1, or I can write p1 by q1 minus into dq1 dp1 is equal to minus 1. If we look carefully, this is nothing but the elasticity. Ep is equal to minus 1 or mod Ep is equal to 1. So elasticity of the demand curve in cardinal utility approach is unitary. From here, this is mu by lambda. So the equation of the demand curve is P is equal to mu by lambda. So now the third part, if the income got changed, then what will happen in the demand curve, or if the marginal utility of money is not constant, then what will happen to my model? So let's try to answer this question. So if income got changed, the name will increase or decrease. So if money income means Q is changing, then marginal utility will fall according to the cardinal utility approach. If quantity rise, marginal utility will fall. So money income is the quantity of money. If that will rise or change, obviously marginal utility will fall or rise. So marginal utility of money, that is my lambda, will fall or rise based on the income increase, income change. So in that case, if you look into my graph, so this is my initial, suppose this is my initial demand curve, mu by lambda. See, if my income will rise, I will shift to the, sorry, I will take another color. Excuse me. Now this is my purple color is the initial demand curve. Now if income rise, the new demand curve will be the yellow one. If the income will fall, it will be the red color demand curve. So how it's going to happen, we'll try to understand that one. So we are considering Q in the horizontal axis, P in the vertical axis. What is the equation of the demand curve? Mu by lambda. Mu is the marginal utility of the commodity and lambda is the marginal utility of money. So now case 1, if M or income rise, then marginal utility of money lambda will fall. Then mu by lambda, this ratio, what will happen? If the denominator is falling, obviously the value of the ratio will rise, so it will move to the higher demand curve. So case 2, if M fall, then marginal utility of the money will rise. So in that case, mu by lambda, if the denominator will rise, obviously this value will fall. Then I will move to the left side demand curve. So in that case, if the marginal utility of money or income will change, so my demand curve will shift to left and right based on the situation of my income. So let's stop the discussion. So thank you.